you. Look at that. Ooh, okay. All right, let's see what happens. Oh, hello friends. Welcome to my science lab again. We are doing some really fun experiments with water today. Come a little closer. Check out this penny. Do you guys see my penny? How water, as I'm putting the droplets on, the water is sitting on top of the penny. It's not falling off. Water is pretty amazing. That is because water has water tension, which means that as long as you go really slow, your water droplets will stay on the penny. And it kind of makes a dome shape. You know, there are so many experiments that can be done with water. Look at how it's becoming a dome. Over time, eventually you'll put on so much that it will topple over, but before it does, it makes a really cool experiment to do. All you need is a penny, some water, a flat surface, and a dropper. Ooh, look at how big it's getting. Do you think I could do one more before it falls? Let's try it. The trick is to go nice and slow. If you go too fast and put too many water droplets, it'll spill all over. You also want to make sure to get no water on your surface, other than the penny. Let's try another one. Oh my goodness! Oh, look at that. Oh, and it finally toppled over. That was pretty cool, though. All right. That was a great experiment. Good afternoon, friends. All right, are you ready for another amazing science experiment? I can't wait. Today, we're learning about water. Water is so amazing. Now, for this experiment, you're going to need some nice cold water. This has been in the fridge all night. You need some nice hot water. Now, I put this on the stove and warmed it up. It's still a little too hot, so I'm going to let it cool down just for a few minutes. You want hot water, but not too hot that you can't touch it. You're also going to need an adult. Because we're dealing with hot water, we don't want any burns. So make sure you have an adult with you. Anytime you do science, you should always have an adult. You're going to need a surface. I recommend something like a tray. I'm using a pie plate because this is going to get messy. I've had to do this experiment a few times before I got it done correctly because if you don't get the water just right, well, it gets messy. You're going to need 2 mason jars, clear jars, baby food jars, some kind of jars that are sturdy. I'm using glass ones because they are nice and heavy duty. I'm going to have 4 though because I'm going to do this experiment twice. You only need 2. Now these are from Halloween. They're my pumpkin lava lamps, which we'll do later on. So don't mind the funny little jack-o'-lantern faces on them. You're going to need some food coloring. I'm going to use red for hot, yellow for cold. Now, this part is very important. You're going to need a piece of laminate paper or plastic. You could use cardboard, but I've never had success with cardboard because it tends to get a little wet and soggy and it just is hard to flip and pull. I'm using cardstock that I laminated because it's easier to put in between and pull because it's slippery. We got a funnel because you never know if you're going to need a funnel. Of course, I got my science goggles because we can't do science without my science goggles. And then if you have the recording sheet, we'll want to make a prediction and do our observations. I hope you're ready. We are going to learn about water density. I don't even know what that means, so I hope this experiment will explain it for me. Let's get started for another fun experiment. Alright, before we begin our experiment, we always have to make our prediction. Our experiment is on water density. Now, because we're using two different colors in our containers, over here, I'm going to draw one jar and write hot, because that's going to be my hot water. One jar over here and write cold. That's going to be my cold water. My cold water will be yellow. My hot water will be red. The reason I'm putting it on this side is so I can distinguish later in my experiment what these meant and what color the hot water is and what color the cold water is. Now for this experiment, we're going to take our hot water and our cold water. We're going to have our hot water down here, and we are going to take our cold water and put it right over top like this and see what happens. So our prediction, we need to draw our two jars like that. And then now that our jars are good, we're going to use a black crayon. There we go. Erase my pencil line I don't need. Now, it looks like that. Perfect. Now, remember, my cold water will be on the top. My hot water will be on the bottom. What do I think is going to happen to my hot water and cold water whenever I put the jars on top of each other? So, let's see. My prediction is that the hot water will come up here and my cold water will start to come down here. So they'll flip. My hot water will be all on the top and my cold water will then be all on the bottom. That's what I think is going to happen. So let me erase that hot water right here because this is going to become all of my cold water. They are going to switch spots. All right. So my hot and my cold will switch. Remember, we started with hot down here. We started with cold on top. I think they're going to switch spots. Make your predictions, my little scientists. All right, let's move our paper. And let's get ready for the experiment. All right, are we ready? Let's get this show on the road. So, the first thing we want to do, of course, is make sure our hot water is not too hot. Perfect, it's hot, but not too hot that we can't touch it. I'm going to use my funnel to start. We're going to pour our hot water. I'll use a beaker to help me over here. There we go. We're going to pour our hot water into our cup, our mason jar. Now you want to get it all the way full to the top. This is where you're going to really want an adult to help you because hot water should never be played with on your own. Oh, I think we can go a little bit more. Perfect. There's my hot water. You're going to want something to stir it with. Remember, our hot water is red. So I'm going to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 drops of food coloring. Stir that on up. Move it to the side. Now my cold water. Again, I'm going to use my trusty beaker to get some of this nice cold water. There we go. And I'm going to fill it right to the top. Ooh, and we can go a little more. There we go. A little bubbly. I guess my mason jar had a little bit of soap in it still. Get those bubbles out. There we go. Alright, we're going to add our yellow food coloring. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Well, let's add a little bit more red in here. 1, 2, 3, 4, 5. Because the more red we add, the darker it will be. Perfect. All right, the next step is you're going to want your card. We're going to put our card over top of the cold water. Press it to make a seal, hold on to it, and flip it. Now this part is going to take some practice. It took me a long time to be able to do this properly, but here we go. So you're going to take your piece of plastic or cardboard, push it on. Hold it with your hand. You're going to want to put your hot water in the middle. Alright, you got to be quick when you flip. Push it down, flip it over. And you want to put it right over top of your hot water jar. A little bit will leak out, that is okay. Make sure it measures up. Now you're going to remove it and watch what happens. Ooh, what is happening? Our hot water moved up into our cold water jar and the colors mixed. That is amazing. Now let's draw what we observed. So, we had our 2 jars. It's okay if your paper gets a little wet. That's part of the experiment. You know what? It'll dry. Now, my prediction was that the hot water would go up, the cold water would go down, and they would switch spots. But they didn't really switch spots. They more mixed. So my red started down here. It traveled up. My yellow started up here. It traveled down. And they ended up mixing to make a dark orange. Wow, that is pretty cool, but you know what? I'm still not satisfied with this experiment. I think we should take it a step further. We started with hot water on the bottom, cold water on the top. We flipped them to find out what would happen. Let's do it in reverse. We will start with cold water on the bottom, hot water on top, and we will flip them. Do you think starting with cold water on the bottom instead of hot will have the same effect? That the water will mix together to make orange? That's a good hypothesis. Let's see if it will make the same result, or if it will do a different result. All right, we are going to follow our same steps as before, but this time we are going to start with cold water first. Our cold water is going to be on the bottom. In our last experiment, our cold water was on the top. Oh, a little bit more. Good. Put my extra water away because a clean science station is a fun science station. All right. My cold water was yellow in the first experiment, so it's going to be yellow again. Put away my crayon. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my cold water, all done. Let's check my hot water. Ooh, we are still good. All right, next up my hot water. Remember, make sure an adult helps you because anytime you're using hot water, it could be very dangerous and you could get burned, especially if it's too hot. We are almost there. A little more. Perfect. In the last experiment, my hot water was red. It's gonna be red again. And we added about 14 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, let's give it a stir. You want to make sure to stir really slowly so that your water doesn't go all over. But if it does, we have a trusty tray. The last experiment, my hot water was on the bottom. We flipped the cold water. This experiment, my cold water will stay on the ground, on the tray. We will flip my hot water. Same thing, you want to take your sealer, put it on top, hold it really tight. You're going to flip and position. A little bit of water may come out, but that's okay. You want to pull nice and slow, holding your top on, making sure that it stays even. Ooh, look at this. When we did it the first time, we had our cold water and hot water mix. The hot water was on the bottom and the cold water was on the top and it mixed. Now we have our cold water on the bottom, our hot water on top. You can see it mixes a little bit at the seal. From when we were taking apart our plastic, some of the hot water trickled down really quickly trying to get out, and it kind of at the seal made it orange. And a little bit orange at the top. But if you look at it, our hot water and our cold water are staying separated. I wonder why that is. You know what we need now? We need our question book to give us the answer. Let's take a comparison of our two experiments. Here's our first one. We had hot water on the bottom, cold water on top, and they mixed together. They made an orange. In our second experiment, we had cold water on the bottom, hot water on top. They mixed a little bit at the rim, but overall, our colors are staying separated. Why does this happen? Let's find out, super scientists. Let's find out. How does it work? The hot and cold water science experiment works because of the different density of hot and cold water. Density is how much mass is in a liquid. That's a little confusing. Let's think of it as a drawer of socks. When you pull out your drawer and there's no socks in it, it's not very dense. There's like nothing in it. It's empty. The more socks you add, the more full your drawer of socks is. So when you have an empty drawer with no socks, there's nothing in it. When you have a drawer full of socks, there's lots of stuff in it. That's what density is. Whether there's lots of stuff in the water or no stuff in the water. But I'm still a little confused. Certain liquids are less dense than others. But water has the same density of other water, right? It's both water. They're the exact same thing. So why did it mix or why does it stay separated? That's what we really need to know. If we use water in both, why is the density different? The secret is in the temperature of the water. The molecules, so the little water droplets, little water bubbles in the hot water move faster than those in cold water. I didn't know that. Hot water molecules bounce around and leave gaps. This makes hot water slightly less dense than cold water. So when you put the cold water on the bottom, the denser cold water, it stays there. It doesn't move. That's why it stays separated. But when you put the cold water on top, heat molecules rise, so the colors mix right away. And because we're mixing primary colors, red and yellow, they mix into a secondary color when the hot water is on the bottom. That's how we made orange. Isn't water fascinating? I sure learned a lot today. This experiment was amazing, but I wonder if we can do another mini water density experiment and see what happens. I have my mini science lab. Let's put hot water in here, push in some cold water, and see what happens. Let's get ready to experiment. All right, so let's take this experiment one step further. Our hot water is red, our cold water is yellow, just like before. So I'm gonna start by putting my hot water in my little beaker in my lab. Fill it about halfway. Now I want to see what happens when I take my droppers of cold water and when I push them into my hot water beaker. What do you think will happen? All right, let's get ready. Hot water, and I'm going to push in some cold water. When I push cold water into hot water, they seem to blend. Just like our first experiment, it makes it orange. Let's try this experiment again. This time, I'm going to take my cold water and pour it in my beaker. Next, I'm going to add my hot water in my syringes. There we go, nice and full. And let's see if the same thing happens. Will they mix? The exact same thing happens. So, when you start out with hot or cold water in a beaker and you push the opposite temperature water in, they end up mixing. Why is that? We already learned our water has different densities, but why, when you mix it together by pushing, does it mix? That's because when you force cold water into hot water or force hot water into cold water, the pressure of the water going in through the tube and into the beaker creates a force. The force of pushing water together, hot and cold, makes the water blend and makes it warm. Just like over here, our water has become warm because the molecules of the water have mixed. I love science because you could do so much experimenting and still have so many questions. This is why I love science. You can do so many different experiments by having one question. And then by doing one experiment, you get even more questions, which means you have to do more experiments. Thanks for tuning in. See you guys next week. Remember, nobody is too small to start having big questions and finding out answers to those big questions. Science should always be a part of your life, because it will allow you to do big, amazing things.